Okay, let us come to number 3. Express the following complex numbers to their to rectangular forms and correct it to one decimal point. For A, Z is equal to 5 outside bracket cos 45 minus 5 I sin 45. So let me rewrite this complex number and then you see it in a correct way. Z is equal to 5 outside bracket cos of 45 degrees uh, minus. So this one there is a bracket. This one is like a bracket. That's what they have missed out there. Minus 5 sin 45 degrees. So this is the way it is written here. There is I here. I. Okay. For this complex number, what do you have to do? You need to find the value of cos 45 and sin 45. So what is the value of those two? So from trigonometric ratios, so we know that cos 45 is the same as 1. 45 is equal to 1, and sin 45 is also equal to 1. So what you have to do, you need to substitute this one with 1. So therefore Z here is going to be equal to 5 outside bracket 1 here. You multiply 5 times 1 minus 5 times I times 1. So to write it in rectangular form, this complex number is equal to 5 minus 5i. So this is the rectangular form of this complex number here. Okay, for B, Z is equal to 6 outside bracket cos 30 degrees minus I sin 30 degrees. So what we have to deal with first is to find the value of cos 30 and sin 30. From here we need to find the value of cos 30 degrees and the value of sin 30 degrees. So cos 30, we know cos is the ratio of adjacent out of hypotenuse. So when we use the triangle here, where this one is 30 degrees, opposite here is 1, and the adjacent is root of 3, and hypotenuse is root of 2. So cos 30 here is equal to adjacent, which is root of 3, divided by hypotenuse, which is 2. So cos 30 is equal to root of 3 divided by 2. So that one is the value of cos 30. It means that you have to replace cos 30 with this value here. So then you come to sin 30. Sin 30 is the same as opposite out of hypotenuse, which is 2. So cos 30 is sin 30 is the same as a half, is equal to 1 out of 2. You see? So till now you get this thing in this way. So now you can now say Z is equal to R outside bracket cos 30 is root of 3 divided by 2 minus I times sin 30, which is a half. Sin 30, which is a half. So now multiply this 6 times those terms inside in the bracket. So this is going to be Z is equal to 6 times root of 3 divided by 2 minus 6 times I divided by 2. Now simplify this by 2, 1 by 2. This is going to be 3 by 2, 1 by 2 is 3 here. So your final answer is equal to 3 times root of 3 is 3 root of 3 divided by nothing. This one is 1 divided by 1, but since it is 1 we cannot write it down. So root of 3 minus 3i. So this is going to be the rectangular form of a complex number. Z is equal to 6 cos 30 minus I sin 30. So this is Z. Okay, the other way you can solve these numbers, you can use what we discussed before, where we say A is equal to R cos theta and B is equal to R sin theta. So to get the real part, the real part of complex number, you have to multiply the R value, which is the modulus, times the cos of the angle, cos angle here. So it will give you the real number. So for imaginary number, you have to multiply the modulus, which is R, times sine of angle, which is 30, then times this. So you can easily get them in those ways. Okay, let us come to C. So for C, let's use that way where we say A is equal to R cos 30. So the first value, the value of R, the value of real number is equal to R, and R here is 0.5, which is a half, 0.5, times cos of the angle. Angle here is 35.6. So A here is equal to 0.5, which is a half, times the cos of that angle. So we can first our calculate here. So we can press our calculate to say 0.5 times cos of 35.6, so which is equal to 0.4. So the first value, the value of real number is 0.4. So let us find the value of imaginary part. So for imaginary part, B is equal to R sine of theta. So and R here is 0.5, the modulus is 0.5 times sine of angle. The angle is 35.6. So therefore the value of B is going to be 0.5 times sine of 35.6, so which is 0.29, which can be 0.3. So to write this one now in rectangular form, we can write it as Z is equal to first number, which is 0.4 plus the imaginary number, which is 0.3i. So this is the rectangular form of C. Finally, so let us do number 4. Number 4 is saying the diagram below shows a point A, B represents on a complex plane. So determine its coordinates. So you are being told to find the value of what? Of A and the value of B. So when you look at this complex number, the angle is given here. This is the angle given. So what you have to look for is this angle to get this value of theta. How do you get that value of theta? It is question unknown. So R is already given. It is 7 units. R is already given as 7 units. So write down R. R is equal to 7 units. That is the modulus of a complex number. What about theta? So for us to get this value here, the value of theta, we have to say theta is equal to 90. This is angle of 90, you see. So theta is going to be 90 degrees minus 90 degrees minus 25.5 degrees. Therefore, theta is equal to 64.5. So this is the value of theta. This is the value of theta. Now, for you to find the value of A and B, just use the formulas. A is equal to R cos theta, and R is the same as 7 here. That means it is going to be 7 times cos theta, and theta here is 64.5. So the value of A is equal to 3.0135. So this can be 3.0, which is just 3. A is equal to 3. Okay, let us find the value of B. B is the same as what? As R sine theta. So B is equal to R. R is 7 times sine of angle, which is 64.5. So therefore the value of B is going to be that 7 times sine of 64.5. So the value of B is 6.318. So which is going to be 6 which is going to be 6. This is going to be the value of B. So, and that is it. You are being told only to find this thing here, to find the value of A and B. So that is all. Okay, thank you so much for watching this video. This is the end. We are going to discuss the uses of complex numbers in the next video. So God bless you. God bless us. Make sure you subscribe to our YouTube channel. Thank you.